everybody. We're about to have a talk about the space station and how you could build your own model space station that syncs to the real thing. If you're interested, come have a seat. We're kicking it off now.
If you didn't hear that, we are kicking off our talk now on the International Space Station Mimic, as you can see here. So come join us if you are interested in learning more. So I'm going to go ahead and get started. My name is Brittany Wellborn. I'm a STEM instructional technologist, and I was introduced to the Mimic at Space Exploration and Educators Conference 2 years ago. And ever since then, I've been really kind of fascinated with it and learning more about it. And as of recently, this last year, I got even more invested into it, meeting up with some of the team and getting roped into some of those educational practices as well. So we're going to go ahead and introduce you to our panelists. All right, here we are.
Hi, I'm Brian Murphy. I'm Associate Chief Engineer for Boeing's Space Station project.
Hi, I'm Susan Freeman. I work on Boeing, also ISS. I'm in flight operations. I do procedures on how to build the space station.
Hello, I'm Craig Stanton. I'm a mechanical design analysis engineer for the International Space Station program. I do a lot of 3D printing, we do a lot of modeling, do a lot of VR development. It's a lot of fun, and we're here to talk about the kind of fun we're having today. You got your own mic. All right.
Hello, I'm Sam Treadgold. I work on the micrometeoroid orbital debris team for the International Space Station. And that's it.
Hello, I'm Chen Ding. I work on payloads on the International Space Station, so I don't actually work on the station itself, but everything that's inside of it, all the experiments and the science research that's currently conducted by the crew, I work on all those.
All right, let's give it up for our awesome panelists today. All right, so we're going to start off with, first of all, here's a little video to kind of introduce you into the concept.
But it's so far. Well, it feels far, but it's only 250 miles up. How can we make it feel closer, more tangible, more connected? Well, we could build a model of it. That's fun. Nice job, Lego. But it's kind of just sitting there. The real space station is active. People are there. Things are happening. The real space station moves its solar rays to track the sun. What if we designed a scale model from scratch using 3D printing, Arduino, and Raspberry Pi, and then put motors in it and made our solar panels turn too? And then what if we used live data streaming from the real space station to turn our arrays to match the real space stations in real time? Well, that's what we did. And we crammed in LEDs and magnets and data screens. Lots of interactive data screens. This is ISS Mimic, an articulating scale model replica of the International Space Station that's powered by real data streaming live from the real thing. It's driven by Raspberry Pi and Arduino. By the way, we can make it go fast and crazy. Most people don't get to engage with ISS, even though the world came together to create it. We are NASA engineers who get to work on the ISS as part of our day jobs. Even though we work on it every day, we don't get to see it, touch it. So a few of us got together and decided to make this model. We envision ISS mimics in schools, libraries, museums, airports, and even homes all around the world, connecting people on Earth with those in space every day. We've been so excited to team up with Space Center Houston and meet with educators from all over the world. We need your input to help make this open source project and also gave us a lot of good pointers on other simpler builds we can do. Teachers, we especially want your input to help leverage students' excitement about space into interest in STEM and STEAM. The International Space Station belongs to you. We especially want your feedback. We created ISS Mimic as a celebration about space into interest in STEM and space to ground. The International Space Station belongs to you, to everyone. We created ISS Mimic as a celebration of human spaceflight and to connect space to ground, to you. We hope you'll join us.
All right, so that is a little brief overview of the ISS Mimic. And as you can see, it really gives you that cosmic perspective that whoever you are, a student, a teacher, just somebody who's interested in technology, it gives you a piece of that outside that space here in life. So we're going to go over a few questions. The first one was kind of what is the ISS Mimic, which was just covered then. But what are some of the applications for the ISS Mimic?
All right, I'll take that one. So we've noticed that a lot of times when you're just looking at telemetry, just numbers on a screen, you don't really get a good sense for what that means, right? You can't grasp what that is. So if you can have an interactive model like this, you can see what's happening. Just in our own concept of building it, we turned it on, had some of the LED lights glowing, and we were noticing one particular light was not on. Or it was a different color than the other ones. And we went, what's going on there? And so we actually called some people and said, hey, what's going on? And it turns out they were having a power problem. Well, you may not have never noticed it by just looking at numbers on a screen, but because you can see it and visualize it in real time, you see what's happening. Recently they had, there was some issues on orbit with one of the Russian Soyuz vehicles where they had a coolant leak. So we were able to see the arrays being pointed such that they were shadowing it to keep it cold so it wouldn't get too hot. We've also seen where they've had some issues, a little bit of leak on orbit in one of the Russian segment pieces. And so we could see the pressure drop just by looking at the data screens here. So it's just interesting to see that we're as real time as NASA's getting the data. And so all of a sudden now you're way more connected with what's going on and you can understand it just by seeing what's interacting there.
I'm going to stand up because some of you are getting cut off by the model. Yeah, so exactly what Craig said, and then further, it's if you're a NASA nerd already, any NASA nerds among us? Yeah. So you have access to tons of apps, their YouTube channel, they're actually great on social media. So if you're already looking for it, you can find a lot about it. We want something that's sort of in the way, right? If this is at an airport or at a school, you're going to walk into this, and then if stuff's moving, it may get your attention. If any of you have flown out of Hobby or Bush, you may have seen a model similar to this there, but it's just static and everyone walks by it. If it has obnoxious LEDs and maybe it's flipping around, it can get some attention. But really, I think the most important aspect is just how this can connect to those who don't normally have that connection to human spaceflight, right? This was made intentionally to be something educators could build in their classrooms, or the public, including adults, could build at a local library. Just with 3D printing and some materials you can buy off Amazon, you can put this together. And in doing so, you learn about all the pieces that make up the space station, and then just connects you, when it's up and running, connects you to what's going on in real time. So it's a different type of connection. I think this would be a good time, Chen, if you don't mind, to run through some, I'm going to hand you the mic and you can talk through what you're doing there.
All right, so right now the space station itself is moving. We are not at the moment, but what we can do is go ahead and actually go live here. Let's go ahead and start with that. All right, so this is what we're looking at right now, is what the International Space Station on the solar arrays are pointing at. And as you can see, the solar arrays are pointing in a very specific direction. And as Brian has mentioned, every time the solar panel are doing is sun tracking. So you can actually tell what the sun position is. And as Craig mentioned a moment ago, a lot of times we actually notice some of the panels are a little off by not pointing at the sun where we anticipate it to be. That's how we know certain position that must be doing maintenance or certain things like that. So having a model able to let us see pretty quickly is everything nominal currently the way that we understand it on space station, and be able to see that pretty quickly and able to ask the question instead of going and through telemetry itself looking at the numbers and trying to figure it out. So this right now is live mode, and it's moving pretty slow. I mean, if you blink, you probably don't even know this is actually moving. But half an hour later, you come back, the solar panel pointing in complete different directions. So as the video suggested, we can make it go fast, but we're also able to put in model data in here. So model data allows us to see how the solar panel behaves, because again, we are trying to maintain the solar panel to keep it as fresh as possible, have the least amount of debris from the rocketry that can deposit on our solar panels. And that is what we can show. And as a newbie that comes in, I know when I first got into this project, I was relatively new. I knew about the science that goes inside the space station, but the actual behavior of the space station, as when the solar panel, when they move, how they move, that was completely new to me. So having the model actually allows me to picture it. When a spacecraft comes in which direction it comes in, and where it's docking, how the solar panel actually can protect itself. That's all part of the programming that NASA are actually able to do. So I'll show you a little bit of that. So this is one of the favorite one that we put together. This is a HTV. It's a Japanese docking vehicle. It's uncrewed, only for cargo. That's docking to the space station. Currently running about 60 times the speed, so sped up quite a bit. And there's our vehicle going. It's running quite fast in terms, because most of the time we don't see a lot of movement as we went through. And having this capability of showing allows the kids, the students, even adults like us who doesn't know how the behavior of the space station itself can see and picture it real graphically, what it's doing, how it does it. And having something with the small motors that we can just get from Amazon and be able to use a Raspberry Pi to make the program, it's very much attainable, right? A Raspberry, relatively cheap, we're able to make that happen pretty quickly. And a lot of the programming we're done in-house. And I'll let Sam talk a little bit about the programming aspect of that.
Sure. So also the telemetry. So since 2011, NASA has had a public service called ISS Live, which is just a select subset of all of the critical data from the space station broadcast to whoever wants to use it. It was relatively unknown, and we all saw that data and we're like, this needs to, independently we thought, this needs to control a model of the space station that mimics whatever the real space station is doing. And I have to tell our hero story. Okay, in 2019, NASA decided to defund this project. ISS Live died. Funny story, it was killed on the very first day that we took this model out to show to the world. That day, we had no idea what was going on. It was dead. And so we mounted, there were a lot of universities and educators who were wanting this data back because it's very valuable data to teach classrooms how to survive in space and what the space station does. So we basically took this model to a bunch of important people at NASA and Space Center Houston, and not entirely due to us, but to pressure from us especially and the community, NASA decided to refund the ISS Live program, substantially because of this model. But yeah, so honestly, even among my career on the space station, I think that's my proudest moment. But so anyway, so this data flows from the space station off this antenna that we don't have here, but we have a 1/4 scale one at our booth. But so it actually goes up into space, goes up 20,000 miles to a bunch of satellites called TDRS, Tracking and Data Relay Satellites. From TDRS, it gets sent down to the ground at either Guam or Maryland or White Sands, New Mexico. And after that, it gets transferred over fiber to the Johnson Space Center. At Johnson Space Center, it goes into public data adapters, which send it out to a company in Italy called Lightstreamer. From Lightstreamer in Italy, they're the ones who push it to the entire world, whoever wants to subscribe to it. It's a little bit of a process subscribing to the data, so our open source code, a lot of people use it to just connect to the data because we've already done all the legwork. So anyway, from Italy, the data comes over the public internet to our model. So that is the journey that the telemetry takes from the space station to right here. And it is why we are about 30 seconds behind what the actual space station is doing, but the data is taking a surprisingly long distance. It goes all over the place before it gets here. And from the when it gets here, we have a Raspberry Pi right here that receives all the data. The Raspberry Pi decides that all of these Arduinos are hungry for telemetry, and it doesn't. I like to say that this was a feature, and it just sends all of the telemetry to every single Arduino, whether or not it wants it. And that was really just laziness on my part, but it turned out to be kind of useful because now you can just plug any accessory to Mimic, like our S-band antenna over there. You can just plug it into the Pi, and it'll just start working, which kind of worked out, but yeah.
Yes.
So Sam, I see a couple of signatures on the back of our Raspberry Pi. Who are those from?
Let's see, these signatures on the back of a Raspberry Pi might be from the Raspberry Pi co-founders who are big fans of our project because we are big fans of them, and the Raspberry Pi is what makes this whole thing possible.
What scale is this? Is this a 100% scale space station?
This is a 100% scale of space station for a 1 to 106 scale human, which is right here. You can see our 1% scale human. His name is Nathan. He was named Nathan at last year's Comic Palooza. And he helps give a sense of scale to how gargantuan the space station really is. But yes, this is a 1% scale model. The real one is 100 times bigger. Space station is the largest spacecraft ever assembled by humans.
Did NASA or Boeing pay you guys to do this?
NASA or Boeing did not pay us to do this. This is a 100% nonprofit volunteer project.
So anybody can create this themselves.
Anybody in the world can create this project. It is 100% open source. Anybody in the world can also join the team and help us out. Hint, hint, nudge, nudge. Coding. If you know Python, if you know Kivy, you aren't leaving this building except in the back of my car. Sorry. Yeah, definitely joke.
Yes, I think coming from the education standpoint and finding the Mimic, it was like, wow, this is so cool, because trying to introduce 3D printing and microcontrollers into schools to teach students those foundational skills that I think are still important, that are lacking in today's education system, really got me interested in this. So what are some potential other applications that you see for the Mimic, the future for the Mimic?
Yeah, sure, I'll take that one. So really what we've been really craving, and maybe we highlighted that in the video a little bit, is educators like Brittany and others that are partnering with us now to really take this from something that's feasible and doable into something that's actually useful to teachers in the classroom and kind of achievable. So a lot of what we like, some of it's serendipitous laziness, but we see like replicating this, the process of it can really tie well into curriculum. We actually just finished, for those of you who are local, the Harris County Public Library System, we finished a pilot test build there. So there's one of these just like this at the library in Clear Lake, Freeman Library, where it was built by patrons of the library. We had 11 nights over the course of several months where they would just show up and incrementally, build parts. Some would 3D print there, or even at their homes. The library has 3D printers. Or they would do the soldering, they would upload the code, and we really see, this is what we wanted, is it's empowering. So we've seen that working in space feels like it's distant, it feels like it's a little unreachable, or it's for other people. We all work in that domain, and we're just regular people, right? Being in Houston, we have an advantage of it's close by. I grew up in a really small town, I didn't know any engineers. And then, I'm a middle-aged white guy, right? I have a lot of opportunities that others don't have, just based on maybe their demographics or where their school is. So the real purpose of this is to get it to people that are on the fringe. And so it can be at this scale. We're working at a much smaller scale as well, just so, do you mind, Chen? And this directly came from feedback from educators, even just this past February at the conference. So this is a much smaller one, simpler one. That's the main part. So that's analogous to like these pieces, not the truss there. But we see that as, wow, this is another way. Students, maybe space is enough to get them excited to try it. And anytime you're trying something new, you're going to try and fail. If anyone ever built their own cosplay or their own robot, it doesn't, in my case at least, it always breaks a bunch of times before it works. So it builds that resilience, but then it's also just some experience with the technology, and you go from an observer or consumer of technology to a creator with technology. And it just seems to change the mindset. So I'm really excited about what that could mean, both in this and in kind of other elements, smaller scale. Another new thing is, this one is with Boeing funding, the Franklin Institute. It's a museum in Philadelphia. They want one of these, and so there'll be one of those there. And then just this week, Space Center Houston said they want to do that as well. So we've had this at Space Center Houston many times for conferences and public talks, and they finally said, yeah, they want one, and they're going to work with the Franklin Institute to try to replicate in even more places. So that's all exciting for us. We're happy that's going on. Any other comments?
Also, something that's come up just recently is it turns out that NASA has reached out to us, and Mission Control themselves want to have one. So that's really cool too, because this is where we have taken this into some of the back rooms before. That's how we learned how far behind we were in telemetry, because we could see real numbers and then see real activity and notice and time lag it, so we could understand that. But the fact that Mission Control realizes themselves the value of this, I can see something, I can push a button on a console for the real unit and see it replicated here and know what it looks like, is actually just, it's like a kind of like a dream come true. It's really kind of fun for us to see how that's working.
The Mission Control thing is tentative. That hasn't been worked out yet, but yeah.
But we want to make that work. We're going to make that work. We'll make it work.
We did have it in Mission Control during the historic all-female spacewalk. Just pretty awesome, and I say that as often as I can.
Awesome. So any other closing remarks that you guys would like to make about the Mimic?
There are different levels that you can do. If you look at this and you think, oh my gosh, this is cool, but I don't think I can do this. First of all, I didn't do I'm older. My coding was Turbo Pascal, C+, long time ago. I didn't know how to 3D print. I've learned how to 3D print. I'm doing some of the coding in the Python and the Kivy. It's much more casual now. But if you look at this and you think it's just a little too much for me to take on, or maybe I don't want to spend that much money, there's other versions that we also have, and they all run off the same Pi. There's a bunch of displays on it. You don't even need a Mimic. You can have the Pi and still see all this stuff. You know, it's not moving around and stuff. We also have other versions that are kind of 2D that light up and do things as well, and run off the same Pi.
Yeah, I'll
and
add.
SASA.
If you have a Raspberry Pi, you can run our image and just watch the ISS telemetry on our awesome data screens that Susan has made without the model. The models are pride and joy, but I frequently run just the image itself on my desk just to watch what the space station's doing at any time.
And I know you guys mentioned the new smaller version. What scale will that be at?
Yeah, so look, this one is 1/100th. It'll be 1/200th, so half as big as this. But you know, that's kind of in 3 dimensions, so I won't nerd out. It's one eighth of the area of the volume. But yeah, I'm going to walk through a little more of this. So Chin, do you mind passing around the motor right here? So just to walk through some of the components, these are all, pretty much everything you see is 3D printed. That one's on there really well. These are attached with magnets. I think I'm dropping our bonus LED. Sorry, team. But these kind of dock magnetically. So all these pieces are 3D printed. These are the solar array wings, the solar panels. These are 3D printed as well, even these trusses. Anyone ever used a Cricut for vinyl cutting? Yeah? So these are vinyl cut, the business side of the solar panels. The motors, which I think is being passed around, those are in here. So each one of these has one of those motors that positions it. It's got a Hall effect sensor on the back. That sensor data is read down back to the Arduinos to close the loop on position. We have a 3D printed gear here. The gear is about this big around. It's actually to scale of the real space station works the same way. It's got a giant 10-foot across bull gear, they call it. And there's a pinion there, so this can all spin together using those same ones. Lots of 3D printed stuff here. It was sized so that basically even a standard size or smaller 3D printer could be used. We have an alternative way to build the solar panels in 2 pieces. This is what it looks like before any paint, and it's also a little bit more robust of a truss. It's not hollow. So we've learned a lot, taking this around a lot of places. We've had pieces break. The good news is you can just print another one. But yeah, so as Sam, I think, mentioned, the Raspberry Pi gets the data, has all the cool touch screens to see the data and manipulate the model. That commands multiple Arduinos, which then send signals up and tell the motors where to go. The LED lights indicate the charge level of the batteries on the space station. So red means discharging. That's when we're like behind the sun in eclipse. Anyone know how long it takes the station to go around the Earth? 90 minutes, thank you. Give them a sticker. Yes, 90 minutes. So sunrise and sunset every 90 minutes. So when it's behind the sun, these are red because it's discharging on the batteries. All the power for the space station comes through the solar panels. So when you're on the dark side, if you didn't have batteries, you might get a little chilly. Yeah, and so then let's see, blue is charging and white is fully charged. Chen, do you mind starting us off another like playback? So for those who joined late, this is an advanced playback of recorded data. This actually takes live data from the real space station via a publicly available telemetry stream. Since that's slow, we also have advanced playback. I think this one will be 60 times normal speed. So 90 minutes, as was said, to do a full orbit, 60 times faster, so this would do that in 90 seconds. Kind of showboats our motors a little bit. Any questions? Sir? Rough overall cost for a school or library. It's much higher than we would like. Again, everything's bought off Amazon or you print it yourself, so it's not like we're charging for a kit. It's about $1,200. A lot of that is the motors and the motor drivers. The Raspberry Pi setup altogether is a couple hundred as well.
A lot of that is also, we have custom printed circuit boards that just clean up the wiring mess. If you did away with those, they're completely unnecessary, and if you just ran a wire mess, you could save at least $200.
You want to say about the Mini? Mini, it should be about $400.
And with the 1/200 scale, the Mini, it should be about $400. So I know I've kind of done some test printing on my own and just using servo motors from around different kits that I've used, and I'm kind of trying to also recreate it instead of the Arduino drivers using microbits. So it should be fun to figure that out. Any other questions for today? Yes, ma'am.
What kind of schooling?
What kind of schooling? So right now we're currently working on
What schooling did we have?
Oh, they have. Oh, okay. Good question.
Yeah, you go.
That's a great question. I changed my major 4 times. My degree's in interdisciplinary studies, so learning all the ways of learning. So yeah, that's about me.
So before we do education, just know that we're just really passionate about space, and that's why this didn't require any degrees to do this. So don't let that stop you. And again, we have educators, we have artists supporting us as well. Yeah, kids. We've proven out that kids can build this, but mechanical engineering, bachelor's and master's for me.
Bachelor's in mechanical.
I actually have 2 degrees in the architecture field. So my master's degree was in space architecture from the University of Houston. There was a talk yesterday by the SIXA organization. That was one that I actually went through myself. So space architecture is a really fun thing, and so here we are, just one more example of things we get to go architect and do stuff.
Aerospace engineering for me.
But also just know that lots of people work in space and to support space. We've got lots of people that do finance, marketing, business development, human resources, all kinds, and we need all kinds, right? And in particular, in this case, we would have been, in terms of what we want to do, we would have been sunk if it was just us engineers, because we really want this to be an education project. So we absolutely need people with other skills and experience to make this actually useful.
We want graphics ideas for our data screens. We want ideas on effectively communicating the ISS information in forms that are not just raw data and animated graphics, and we just want ideas. So feel free to contribute.
And the booth, this will actually be set up right over there. So if you do have more questions, feel free to come visit the table right over there.
We're only halfway through our time.
Hey, and if you go to issmimic.space, you'll see that video. You'll see a bunch of links. We have Discord. We have everything. And they will answer every question you have on Discord about building one of these or probably anything else.
How are we on time? Good.
So it's gonna be right next to the Creator Space booth right here. So you'll see it there. Do we have any other questions? All right, and I know Brian mentioned the Freeman Library had their own model. So if you're in that area, I believe June 10th, they're doing an opening ceremony. So come check it out if you are there. Or even if you're not around, come drive down.
Yeah, and afterwards, yeah, like I said, we're just around the corner. It's like 20 paces. Come by. We'll let you like press buttons and make stuff move around. Good? Anything else? All right. Well, thank you very much.
Thank you, guys. Give it up for our awesome panelists today. Yeah, let's hear it.